In last lecture, we learned about number systems, which is real number, rational number, irrational number, and integers, natural number, and whole number. Now, one interesting question could be, which of these numbers are the larger set? And when I say set basically in mathematical term also means group. So let's look at some of the examples and it will be very clear to us. Let's look at natural number. Natural number starts from 1, 2, all positive, 3 and go up to infinity. Similarly, if you look at whole number, they are 0, 1, 2 and go up to infinity. Now, if you compare natural number with whole number, it will be immediately obvious to you that whole number set is slightly bigger than natural number. Why? Because we have added 0 here, right? But the question is, how many numbers are there in natural number? You would say they would be around infinity. And if we talk about whole number, even that answer would be infinity. How is it possible that one infinity is bigger than other? Now this is a bit counterintuitive, but in maths it does happen. Mathematicians do talk about different kind of infinity. And we can actually say the infinity which is of whole number can be bigger than infinity of natural number. This is obvious. Now let's look at integers. What are integers? We know all the negative number. Okay, negative numbers and even positive numbers, right? Immediately it is obvious to us that integers are definitely bigger than your whole number. Why? Because if you draw a number line, if you look at whole number, they would be only on, or natural number, they are only on this side, whereas as far as integers are concerned, they would be on both sides, right? And you could actually say that z is virtually equal to, if you look at size of set z or group z, it is 2 times size of natural number or even whole number So does it mean the infinity which is denoted by z, is this some kind of 2 times the size of infinity which is denoted by number n? You could say it's that, and this is one way of thinking about it, and this will basically tell you they are different kind of infinity. Now comes a very interesting different question. How about real number, which are r? And if you look at number line again, the real number, it will become obvious to you, they are not only are natural or whole number, but they have numbers in between. All these numbers are also part of real number. So clearly these numbers are much bigger than integers. So we could safely say that real number set is definitely bigger than integer. And we could say the numbers in real number, which is some kind of infinity, is bigger than infinity, which is represented by integers, right? There's another very interesting way of looking at same phenomena about real number. For example, if I draw all the natural number 1, 2, 3, 4, 5, 6, and I can go on up to infinity. And at each line, let's say this line I take, I can go on creating real number of each line by dividing this number 1 by all these natural numbers. So I could say 1, 2 and 2, 1 by 3, 1 by 4 and so on and so forth. And similarly I can repeat this exercise for 2 also, 2 by 3, and I can go on extending to infinity, and you could see same exercise can be repeated for all the natural number. So clearly this set which I see below is not, it's not complete real number set, because it doesn't, this set is not representing irrational number, but still you could see this is much bigger than natural number, right? And even if you look at negative side, same thing can be repeated. So basically we clearly know that real numbers are much bigger than integers or natural numbers, right? Now let's come to difficult question. Now, irrational number, we know that we have studied in last lecture that they cannot be represented in form p by q. Okay, they cannot be. Whereas rational number, we know that they are in form p by q. Now the question is, if I denote irrational number by number s and rational by q, the question is which one is bigger, irrational or rational? Well, our intuition would say that probably rational numbers are bigger because we play with them, we know about them most of the time. Whereas irrational number we are not so familiar with, right? Let's see whether that is the case. Suppose I express a decimal form and I write first digit 1. Now when I am writing a second digit, right, I have a choice of writing 1, or I can write 2 or 3 or 4, and I can go up to, let's say, 9 and then 0 also. So now what do we see here? And similarly, I can look at third digit also, right? I have a choice of writing from 1 to 9 or 0. Now notice, only when you write 1 or 1, it becomes a repeating. It becomes repeating. And then only it is rational. There is one more condition when it is rational. If all the digits after this can be repeating, you can have a 0 here. But that basically means there are very few rational number you can create with this method. Whereas number of irrational numbers, the choices are pretty, at every digit you have close to 9 choices, whereas in case of rational number you have only one choice, right? So it basically says, it's immediately obvious to us that number of irrational numbers are more, right? So we could say S is bigger than Q. And how many irrational numbers are there? Infinity. And we could say infinity, which denote irrational number, is much bigger than infinity, which denotes rational number. This is a very surprising result. But if you look around yourself in nature, this is not so surprising. Why? Because we see nature, there are abundance of irrational number. And look at this example where we have a right angle triangle and side 1, we would find that hypotenuse is root 2, which is an irrational number, right? Similarly, you look at circle and you will find, suppose circle has a radius of 1, you will find the area is pi 1 square, which is equal to pi, and pi we know is an irrational number. Similarly, if you look at a cube, and these are the examples which I am giving from naturally occurring phenomena. Look at cube, and you will, if you want to find out a diagonal of cube, which is from here to here, this number, if the side is, let's say, 1, 1, 1, this number is under root 3. How do we get that? 1 square plus 1 square plus 1 square of under, right? So that is the situation what we see. The irrational numbers are more than rational number. It is very counterintuitive, but that is true.